Hello everyone, today we'll look at how we can create multiple enemies for our tower defense game. So we'll cover throughout this video the concept of the entity command buffer and what is a structural change. And we'll also have to discover what are tag components, and it will give us the opportunity to speak about the IEnabled component. And we'll also have a look at the ordering of systems with the attributes UpdateAfter, UpdateBefore, and UpdateInGroup. Let's get to it. As you can see, I went ahead and copied the third folder, the spawning folder from the GitHub repository linked in the description below. And I've imported it into my project for this tutorial series. The folder structure remains the same, and if you go to the spawning scene, you will see that the spawning subscene has a similar layout as the previous episodes. We have the waypoints, which are defined on the scene. So even if we can't see them because there is the picking only authoring entity we've seen in the previous episode, the waypoints are defined below a spawner, and the spawner will define what entity prefab it will spawn and at which rate it will spawn it. So if I put a spawn interval of 0.2 and enter play mode, you can see that I'm spawning several entities every 0.2 seconds and that they are running in circle around the waypoints. So let's first take a look at the baking workflow. Let's have a look at how we can bake this information into an entity for it to spawn the enemies every few seconds. As you can see in the spawner authoring script, we have exposed a game object for the enemy prefab, not an entity, a game object. We also have exposed a float field for the spawning interval. And we get the path that the entity will follow through the children of the spawner game object. Then in the baker, first thing we get as usual the baking entity, so the entity we will be creating from this game object in the subscene, which is our spawner. This time we use the world space flag because we wanted to have a location in space, but we don't care about moving it, so we don't need the local transform component. Then for the spawning, we add the spawner data, which is a normal I component data. The difference here is that we are storing the enemy prefab as an entity field, and we are also storing the next the spawning interval and the time until the next spawn. So these two fields can be populated as usual in the baker. We populate them from the authoring value we have in the spawner authoring. And for the entity field in the spawner data, we need to actually do another get entity on the game object that represents our prefab. So that will tell the baking workflow that we also need this game object to be converted to an entity. And moreover, it will tell it to be converted as a prefab. And for this one, we actually want our enemy to be able to move after we have spawned it, so we will use the transform usage flag dynamic. And finally, we store the path for the entity to follow on the prefab itself, on the prefab that we will spawn, using the waypoints and the dynamic buffer as in the previous episode. Now that we have baked our entity, we can have a look back at the editor. If we look at the entity hierarchy, we can see that we have our subscene, and within that subscene we have two entities, the spawner itself and the path follower, which is the prefab we defined on the spawner entity. If I look at the spawner, we can see that this entity is a prefab because it's highlighted in blue. And if we look at the inspector for that entity, we can see that we have the tag component prefab. A tag component is a normal component, but it doesn't contain any data. So if we have a look at the definition of the prefab tag component, which is defined by Unity entities, we can see that it's a normal struct prefab that implements the I component data, and it doesn't contain any information. This is useful for when we want to distinguish between different entities that have the same data, but we want to group them in different categories. That can be used, for instance, for state machines or other category-based processing. This tag component is a bit special because it's defined by Unity and by default is not considered when we have entity queries. So if I look at the pass follow system we had in the previous episode, when I'm doing my system API query, it will not return any components that have this information or these components if they have the prefab component. If I wanted the system to also run on prefab entities or entities that have that prefab tag component, I would have to add the with option and use the entity query option include prefabs. So by default, this is not the case. I want my system to run only on the actual entity and not on the prefab itself. As I said, the tag component can be useful in use cases like state machines. But if a tag component represents a state of a state machine, it means that we'll need to add and remove the tag components based on the state of our entity. And adding and removing component is what we call a structural change. Without going into too much detail, if we have a look at the way we store the data in ECS, we have already discussed about the notion of chunk. So if I take a color code for the data, let's say orange for the transform, red for the else, and blue for another kind of data, this set of data constitute what we call an archetype. And that archetype is stored in memory in a chunk, so an area of memory where we store all the entities that have all of these three components. If we now add a tag component, so let's say we have two entities, they're not really stored like that, but if you want more detail on the layout, you can have a look at the other video I made on the topic. So if one of these two entities has a new data that is added, so let's say we have a new data type which is green, then it means that it doesn't match anymore the archetype for that chunk of memory. So this archetype is this chunk of memory is just for the archetype red, orange, and blue. So that means I need to create another chunk of memory somewhere else for me to be able to store a new archetype, which is the orange, red, blue, and green, and take that entity, move it from the chunk of memory it was in originally, and put it in the new area of memory that I allocated just for this archetype. So as you can see, a structural change involves a lot of operation, and it also involves allocating new memory, or at least copying some memory. In the worst case scenario, it means allocating new memory to create a new chunk of memory for the new archetype. So to avoid that, we have the option to have another type of tag component, or a more general sense of the term, another type of component, which are the IEnabled component. We can actually have a look at one of them right here in the inspector. So if I take my prefab pass follower, I can see here that I have another tag component because it's in the tag section, which is the simulate tag component. And there is a little checkbox next to it, so I can't click on it because I'm not in play mode. And we can see that we have this simulate component on every entity we have. So if we want to demonstrate that, we can take the spawner, for instance, pick a higher value for the spawning, so let's say 1.33. And if I go back and enter play mode, you can see that our spawner is active while simulate is true, and I'm spawning a new entity every 1.3 seconds, as you can see in the hierarchy. If I disable the simulate IEnabled component, the spawner is no longer spawning any entities. If I enable it again, I'm spawning new entities again. And to be clear, an IEnabled component is not necessarily a tag component. Like we said, a tag component is an empty component that serves only to identify a set of entity we want to operate on with a specific system. An IEnablable component can contain data. It can also be useful for state machine to store actual data related to that particular state, for instance. But there are two different concepts. The tag component is an empty component. The IEnablable component is a component that can be enabled or disabled without structural change, whereas the tag component, if you want to add or remove it, it needs a structural change. Okay, so now let's have a look at how we actually are spawning those entities in our system. So going at the spawner system, we can see that like in the last video, we have a partial struct that implements a system. And this time we are actually using the onCreate method. Because for us to spawn the entity, we will need what is called an entity command buffer. So to perform structural changes, you can either do it through the entity manager, or you can do it using an entity command buffer. An entity command buffer will allow you to postpone or to delay the execution of your structural change to a certain step in your frame or to a certain point in your frame. So that allows you also to queue up commands in parallel systems. So we'll see that in a further video. For a simple use case like that, we could also have used the entity manager to directly spawn the prefab. But I want to demonstrate the entity command buffer in this video. So Unity defines a few systems that already allow us to use entity command buffers. I've listed all of them here, and today we'll use the begin initialization entity command buffer. You can actually have a look at where they are exactly if you open the window entities systems, and if you have a look at command, you will see all the entity command buffers or all the systems that expose entity command buffers. So as you can see, the begin initialization entity command buffer is the very first command buffer. And if I remove the filters, you can see it's actually the very first system that executes in the loop. So that's the first system of your player loop. Going back to the code, we can get the entity command buffer through a singleton. So a singleton entity is an entity that there is only one of in the world of ECS. And we get that entity to create the command buffer using the world unmanaged as parameter. This will give us an entity command buffer. Next, in our system, like before, we use a system query to get the components we need. For this one, I've added the with simulate IEnablable component tag. So that's how I demonstrated we can stop the spawner from spawning new entities in the inspector window or in the editor. And then what I do in the system is that I compute if I've reached the next time to spawn an entity. And if that time has come, we can create a new entity using the entity command buffer, instantiate, and passing in the prefab entity we want to duplicate or to clone to make a new live entity for our game. What we need to be aware here is that since we are using an entity command buffer, we are not really creating the entity yet. what we are creating here is a temporary reference. So if you were to debug the entity index we have here, you will actually get a negative value. So it's not a valid entity, but it allows us to use that entity reference with a negative index in other entity command buffers that we have to do to create our entity. So in this example, I'm using another entity command buffer command, which is a set component on that entity that I just created. So for now, it's a temporary entity. And I'm actually setting the position to be the position of my spawner. So the entity is spawned at the location of my spawner. And then I'm using another entity command buffer to add the waypoint buffer to my instantiated entity. And I'm copying all the waypoints from my spawner to my entity that I just spawned so that it can follow the path for itself. If we go back to the top of the system, we can see that in the onCreate method, we have the require for update begin entity or begin initialization entity command buffer system singleton, meaning that this system, so begin initialization entity command buffer system, that's a mouthful, needs to be created and running before I'm actually updating this system. So I need this entity to exist for me to be able to create the entity command buffer. So that's why I have the require for update here in the onCreate method. And the last detail I want to point out is that I'm using an attribute here, UpdateAfter. So there are 3 attributes that allows you to control where the system will be updated in your player loop. We have the UpdateAfter, which will tell the system to update after another system or another group. Like here, I'm telling the system to update after the transform system group. I could also have an attribute to say, okay, I want the system to be updated before. And in that case, the system would have to be updated before the system I pass in the attribute. Or I could say, okay, I want the system to update in a specific group. So in that case, it needs to be a component system group. Here, I'm saying that I want this to update after the transform system group, so that if I'm to spawn an entity based on the location of something else, in that case, the spawner, even if it doesn't move, I'm sure that the entity that I'm copying the transform from has been updated. And one thing you need to be careful also is, so if I look at the system, if I were to create an entity after this system, but before the presentation system group, the transform of the entity I just created could still be 000. So if you ever spawn an entity and have it rendered or flicker at the world origin, it's probably because your system order is not correct. But since I'm using the begin initialization, even if I'm queuing the command to instantiate the entity after the transform system group, the actual entity will not exist before the next frame, so it will have time to be updated by the transform system group before being rendered. You also need to be careful about which command buffer you use or which command buffer system you use when you queue up commands. Because, for instance, if you were to create an entity command buffer for the begin initialization, where you queue up a command to destroy an entity, and then you have another system that for that same entity queue up a set component in the end initialization system, for instance. In that case, the entity would be destroyed before the command for setting the component would be executed. So this command would fail. My advice on that is to pick a set of command buffers and always perform the operation in the same order. So For me, for instance, I create my entity in the begin initialization system. I usually set the components or create or add components on the end initialization system. And if I want to destroy an entity, I either do it in the begin simulation or in the end simulation entity command buffer systems. So that I'm always sure that the end or the destroy command basically will happen last. Next, we will put in practice what we just learned today and add in a bit of physics to be able to place towers on a specific spot on the terrain. And as usual, if you like this content, don't forget to like and share the video. If you want to support the channel, you can use the asset store link, affiliate link in the description below. Or like Neil did, thank you Neil, you can support us on Ko-fi also, either with a single donation, like Neil did, thank you again, or through monthly subscription. I'll see you in the next video.